Now let's consider something else interesting. And that is, for example, something related to gyroscopes or something. So let's imagine that I have a wheel here, and the wheel is turning like that. Okay, so that is going to have an angular momentum, and the angular momentum is going to be pointed out. Right hand rule. Angular velocity and angular momentum in the same direction, so that's pointing out. Okay, now if I wheel, this is side view, so there's the axle of the wheel and it's sitting and turning. So if it's turning in such a way the top of it is coming towards you and the bottom of it is going away from you, that would be angular momentum and angular velocity to the right. Okay, now if I have a wheel here and I have the axle and I were to support it right here, everything's fine because the center of mass is right there. So if I'm supporting it right over the center of mass, gravity pulls down, and that's one thing. But if I hold it by the edge of the axle over here, then gravity pulls down. R is like that. Okay, so right hand rule, R cross F, that's torque. So that would be a torque. In this case, torque is 0. Why is torque 0? Because R is 0. Okay. In the case on the right, though, the torque, R cross F, is going to be into the screen. Okay. Now, what does that mean? So this is a side view. If I were to look at it from a top view, okay, or even a side view, if the wheel's not rotating, I try to support it here, gravity pulls down here, R, so torque into it means rotating that way. And so that means it's going to fall down. Well, duh, you don't really need calculus to know it falls down. But top view, if it's spinning, something else is going to happen. So if this is a top view, okay, if it's spinning so that L is this way, but I have torque that way. Okay, again, side view, like we were just doing here, I'm supporting it here. Okay, if L is that way, but if torque is into the page, then what that means is I'm adding angular momentum this way plus angular momentum that way. Because torque is change of angular momentum. That means we add the two together, the final is this way. Well, that would say instead of this thing falling down, it would fall sideways. Okay. Now, this is a favorite example I like to do, a demo that I do in class, and I don't have the demo with me. I didn't get a chance to go to campus and get it. They're still asking us to schedule time to get to campus to get things. So I'll try to get it and maybe get a video of it. But I did find a video online, and so I will link to that video online of another professor doing the exact same experiment, and you can actually see it working. And so I think this is a really cool thing, and it relates to precession of a gyroscope. It also relates to precession of Earth. There's torques that act on Earth. Okay, gravity and forces act on Earth as it rotates, which means it changes the direction it's pointing in space. That changes the positions of all the stars in the sky. And so that's an interesting sort of thing beyond where we need to be in this class. It's really cool, but it is a fascinating sort of thing that happens. And so I will link you to this other professor's thing, and when I get a chance, I'll try to video and post it as well. But that's kind of the end of chapter 11 topics right here. And so I just wanted to get to that and give you a chance to look at it and think about it.